This is video 3 of the Psych 642 Factorial ANOVA assignment. I'm going to pick up right where I left off when the recorder cut me off for video 2. I had just finished setting the contrast for the simple effects analysis and was about to create the model using the AOV function. And you can see that the outcome is still anxiety score, but the predictor variable is just the variable that was created at the very beginning of this process called simple, that includes both of the factors in it. And once again, all this is coming from the anxiety treatment data set. So I'm going to go ahead and create the object that specifies that model. And then I'm going to use the summary.lm function to run the contrast that I set up so that we can see those specific comparisons for the individual effects. So I'm going to run that, and you can see down here the output has come out. There was nothing significant when looking at just treatment. So when comparing the scores from treatment 1 to treatment 2, there was no significant difference, which matches the results that we got from the overall model that we ran earlier. And then looking at treatment 1, there was no difference by gender, which we can see here, but treatment 2, there is a significant difference. And whenever we go to put this into the summary of the results, I'll show you exactly how that plays in. So now that we've done the overall model, found that there was an interaction effect, did the simple effects analysis to get a clearer picture of where that interaction is actually happening, which it turns out is on treatment 2. There's that difference between the two genders. Next, I just want to graph this. That way we can actually maybe see the interaction. So I've done this using the ggplot function. The ggplot function specifies where the data is coming from, so which data set, and then the two factors, gender and therapy, in here, as well as the outcome. So therapy will be on the x-axis, anxiety score will be on the y-axis, and then the two separate lines will be gender. Then I use the stat summary function several different times to add in different graphical elements to this. The first is the points that represent the means of each of the groups. The second is adding the line that connects the dots. And then finally, I'm adding the error bars based on the confidence interval. And then the last element to this graph is, of course, the labels, which I've already mentioned. X is type of treatment, Y is the anxiety score, and then the color of the lines is the gender. So I'm going to go ahead and run this, and then we'll take a look at this graph. Okay, there we go. And then we'll take a look at this graph, which we can see right here. So this actually does show exactly what we just found with our simple effects analysis, that on treatment 1, the anxiety score for males and females was close to the same, whereas for treatment 2, it appears that males have a much higher anxiety score than females, which could indicate that females respond better to that treatment than males do, whereas both males and females respond to treatment 1 approximately the same. So now that we've graphed our interaction effect and kind of looked at that, the last thing that I want to do with graphing is look once again at some assumptions. The first is going to be looking at the homogeneity of variance and looking specifically for heteroscedasticity, and then also looking at the normality of residuals, which we can do with the plot function. So I'm going to go ahead and run that. So this first graph does show that there could be a problem. It pretty much echoes what we found at the beginning with the Levene's test with the homogeneity of variance. This does indicate the heteroscedasticity is happening because it's more of a funnel shape, where the data points are much more spread out in one space of the graph than in the other. So that's the problem. And then this next graph shows that the residuals are not very normally distributed. They should be hugging this dotted line. You can see that it's not perfect. It's not really doing that incredibly well. So that's another problem as well, and a limitation to the results that we're finding with this analysis. Alright, so the last thing that we're going to look at is effect size. So effect size can be looked at two different ways. We can look at the overall effect of the main effects as well as the overall effect of the interaction effect using omega squared, or we can look at the effect size of the simple effects that we looked at using the MES function, which looks at the differences between the means for the effect of gender at different levels of therapy. So we're going to do both. In order to do the omega squared, I have to write a function. And you can see the first 4 lines of this code specify the calculation of the mean sum of squares, which are then used to calculate the variance component of the effect size is done next, and then after that the variance component for each factor as well as the interaction is done here. Finally, the last 3 specify what the actual output of this function is going to be, which is the omega squared values, which are the variance for each specific variable divided by the total here. And that'll give the effect size for each one. So I'm going to go ahead and run this to create this function. And it appears that something is not right. So I'm not really sure what was wrong with it. I just went back and hit run again, and it seems to have worked just fine again. So the code must all be correct. So now that the function has been created, we can use the function, and we're going to use the output from earlier to get a lot of these things. So n is the number of each, the number of participants in each group. A is the levels of factor A. B is the levels of factor B. SSA is the sum of squares for factor A, sum of squares for factor B, sum of squares for the interaction, and then the sum of squares for the residuals. All of that can be found from the original output. Oop, I think I passed it up. So I'll be using this this output right here, which is output from the original model with the type 3 sums of squares. So you can see that the SSA is gender, and then the SSB is therapy, SSAB is the interaction, and then SSR is the residual. So I'm going to go ahead and run this, which then gives the effect size for all three of those. Then the MES, like I mentioned before, compares the differences between the means. So what I've done here is input the males and females averages and standard deviations, and then the number in each group for treatment 1, and then again for treatment 2, to get the effect sizes of each of those specific effects. So now that everything has been run, I'm going to explain how the output is converted into a summary of the results. Alright, so the first thing in the summary of findings is an explanation of the main effects. So first of all, there was that significant main effect on gender, or of gender, on the anxiety scores of participants. You can see that the information for this, the F value, the P, and the P value come from this first ANOVA done with the type 3 sums of squares. Right here, which was significant. The second main effect was that of therapy, which was non-significant, which that information can be found right in here. The F value as well as the degrees of freedom. Now the effect size for both of those, remember we did that at the very end. For the main effects, that would have been the 0.364 for gender and the 0.014 for therapy. Now we did get an interaction effect, so we don't really look at the main effects per se. They can't really tell us what we need to know, because we can't look at them individually. We have to look at the way they interact, since their interaction is significant. So that's the next part of this. There was that significant interaction effect between the type of therapy received and the gender of the participant on the participant's anxiety score, and that can once again be seen in that type 3 sum of squares ANOVA test that we did closer to the very beginning. We see that it's significant with an F value of 15.44 with 1 degree of freedom, or 1 in 44 degrees of freedom. And then once again for the effect size, that was at 0.144, which is a relatively small effect size, whereas the main effect of gender was a relatively moderate, and then therapy was non-existent in and of itself. The most interesting thing that we found with this study was that so the most interesting thing was found in the interaction effects and looking at the simple effects, which showed that males had significantly higher anxiety scores than females after receiving treatment 2, which you can see right here in this output from the simple effects analysis. The means and standard deviations were also included in reporting the simple effects analysis, which we can get from these descriptive statistics right here and where we did the interaction. Finally, the effect size for these comes from the